And we move to the third presentation, which is the validation of bioelectrical impedance analysis against dual energy X-ray absorptiometry in assessing body fat measurement among adults by EKS Jayathilaka, KADC Gunesekara, and EPDS Ediriweera, and the paper will be presented by Ms. E.K. Sarangi Jayathilaka of the Department of MLS, Faculty of Allied Sciences, KDU. It's over to you.
Thank you, sir, for the introduction. Good afternoon to you all. Our research study topic is validation of bioelectrical impedance analysis against dual energy X-ray absorptiometry in assessing body fat measurement among adults. What is more prevalent, communicable diseases or non-communicable diseases? According to the WHO non-communicable diseases country profiles, non-communicable diseases are estimated to account for 75% of total deaths in Sri Lanka in 2014. But communicable diseases are accounted for only 25%. From that 75%, cardiovascular diseases take the majority, that is 40%. It is obvious that we should pay more attention regarding the non-communicable diseases. What is overweight? What is obesity? Overweight is excess weight related to height. Obesity is a medical condition in which excess body fat has accumulated to the extent that it may have adverse effect on health, leading to reduced life expectancy and no increased health problems. Next, move on to the prevalence of overweight and obesity in globe as well as in Sri Lanka. You can clearly see, although there is a low prevalence of overweight and obesity in Sri Lanka compared to global figures, local studies show a definite upward trend in the prevalence of both overweight and obesity. Importance of the present study: prevention of comorbidities of obesity such as cardiovascular diseases and type 2 diabetes mellitus among Sri Lankan has become a major challenge due to the upward trend of obesity. Valid, user-friendly, cost-effective measurement of body composition has become more important for epidemiologic and as well as clinical studies in the Sri Lankan context. Therefore, to achieve such measurement, a validation of BIA is absolutely important. Objective of our research study is to validate the BIA method against DEXA in estimating body fat among adults. We use two methods. For the DEXA, we use Lunar scanner, and for the BIA, we use Motex machine. In the DEXA, both DEXA and BIA measurements we conduct on the same day after subject had fasted for more than 8 hours. Before the DEXA measurement, weight and height were measured, and you can see here in the DEXA, subject lying on supine position with arms on sides. We use medium scan mode and scanning time is 20 minutes. Weight, height, age and sex entered manually into the system for software analysis to derive body fat percentage and body fat kilogram. In the BIA measurement, you can see subject stand on base plate with bare foot and hold arms 45-degree angles. With fingers should touch hand electrodes. Height, age and sex entered manually into the system. In the BIA machines, there were inbuilt prediction equations. From that, we derived body fat percentage and body fat kilogram. Methodology. Study design is descriptive study with analytical part. Study setting, Navaloka Hospital, Colombo. Sampling, all the consecutive persons who fulfill the criteria were recruited to the study. For the data analysis, strength of association between two methods we were estimated using Pearson's correlations, and simple and multiple linear regression analyses were performed to obtain regression equations for converting body fat percentage and body fat kilogram to DEXA equivalent. Statistical analysis was done by using SAS software. Results and discussion. Our sample size is 66. From that, only 5 males and majority is females, that is 61. In the mean column, mean age is 61.75. That means majority in the older age group. And you can see there in the mean, BIA tends to give lower value compared to DEXA for both body fat percentage and body fat kilogram. Strength of association of body fat percentage and body fat kilogram for DEXA and BIA. For the body fat percentage, R value is 0.64. For the body fat kilogram, 0.89. There is a high strength of association between DEXA and BIA measurement for body fat kilogram than body fat percentage. Next we done regression analysis. First, simple linear regression. This column regarding the body fat percentage. This is body fat kilogram. These are the equations we derived. For the body fat percentage, R squared value is 0.9.2%. For the body fat kilogram, 78.0%. Sorry. In these two scatter plots, you can clearly see for the body fat kilogram, there is less dispersion compared to body fat percentage. Next we done multiple linear regression. This is the regression equation for converting BIA derived body fat values to DEXA equivalent body fat kilogram value. You can see both weight and sex are significant in this model, and prediction improved to 78% to 92.5% after adding these variables to the model. Next, move on to the discussion. 90.5% of variation in predicted body fat kilogram for DEXA is attributable to the variation in body fat kilogram measurement by BIA with this model. In most of previous studies models, body fat percentage instead of body fat kilogram was used as the prediction variable. But in our findings, body fat kilogram is the better indicator to predict body fat. In conclusion, our sample size is considerably low and higher percentage at the older age compared to other published data. Further study should address larger sample size with wide age range and exclusion of subjects having major systemic diseases, because systemic diseases give rise to abrupt changes in body composition. These are some of my references. Acknowledgement. Our special thank goes to Professor Lal Chandrasen, Director General Manager, Nawaloka Hospital, Colombo, for his immense guidance and providing an opportunity to conduct our research at Nawaloka Hospital. My deepest gratitude to my supervisor, Dr. KADC Gunesekara, who has supported me throughout this research. My special thank goes to Dr. Ediriweera for his guidance for data analysis. Thank you.
Thank you very much for that presentation. And I have no affiliations with that presentation. I was only providing the facilities, right? Anyway, shall we have some comments from the audience?
Thank you. I'll go slowly. can you tell me what is the difference in cost between the two machines? And what is the difference in radiation exposure or similar effect between the two machines?
Yes. These are that you can clearly see in DEXA there is high radiation and it is costly, but in the BIA it is fairly with less cost, and there is no radiation in BIA machine.
So again, from a lay perspective, why then there doesn't seem to be that much variation in detection of body fat between the two machines? So if that small amount of variation isn't critical, surely one would just select the least expensive machine?
Sorry?
I'll try again.
Go ahead.
From your presentation, it seems between the two machines... Sorry, I'll start again. From your presentation, it seems there is a fairly small variation in detection of body fat. Is that correct? So, do you think that small variation is clinically important? And if it's not, would it not then guide you towards using the less expensive machine?
Although there is a radiation in DEXA machine, it is used actually it is used for not for the body fat measurement.
Yes.
Utilize it for
Yes.
It's used for bone density measurement.
That's it.
That's
Yes.
right.
Yes. Now we are talking about, I mean, DEXA scan is about what, 7,000 or something rupees,
Yes.
versus BIA is what? The minimum. What is the cost of a BIA?
No cost actually.
No cost. 7,000. So that's the difference.
Okay. Thank you.
Any other? If there are no other questions, I can, if I may, add a few comments. Now, DEXA scanner, as you said, it is for bone mineral density. It does the bone mineral density, and also BMI. So it's a part of the report, right? But your BIA is exclusively for that purpose. But from the DEXA scan, you can get the bone mineral density and BMI. So DEXA is the gold standard for this. So most people don't have access to a DEXA to look at the BMI. So this would be a better method to when you standardize it against age and sex. So BIA would be a suitable alternative for spending 7,000 marks. But again, your sample size is 5 versus 61, so you see the females, I don't want to make a comment, you got 61 versus 5. Any other comments? Anyway, thank you very much for the presentation.